Hello everyone, I am Anupam Guhai and I welcome you all to the session on figures and lists in LaTeX. Today I will guide you through some important features of document preparation that are essential to creating professional and polished LaTeX documents. In this session, we'll explore two main areas. First, we'll look at handling figures. This includes how to include graphics, add captions and references, position figures effectively, and customize figure numbering. Then we'll dive into list making environments, covering how to create ordered list with enumerate, unordered list with itemize, descriptive list, and even generate some custom commands for list. Learning these skills will enable you to add clarity, structure, and visual appeal to your documents. Whether you are preparing a research paper, presentation, or any professional document. So, let's get started and unlock the potential of LaTeX for your projects. Figures in LaTeX. In LaTeX, figures are a key way to include images, graphs, and illustrations in your document. They help in visualizing data, enhancing understanding, and adding visual appeal to your work. LaTeX provides a structured way to include and manage figures, and it's essential to know how to handle them properly for consistent formatting. A package is a file or collection of files containing extra LaTeX commands and programming which add new styling features or modify those already existing. Now let's see some of the options which you can use when including graphics and figures.
Including graphics and figures. For including graphics and figures, we need to use the GraphicX package. This GraphicX package provides enhanced support for graphics. We include the package using the command /use package, then GraphicX inside the curly brackets. Considering you have some knowledge about .text file, this is a text file which consists of a document class, the article, having a title, the author name, and a section, figures in LaTeX, with a subsection including graphics and figures. Let's include the package GraphicX. The basic syntax for inserting images is /include graphics and file name inside the curly brackets. This folder contains the .text file and also includes an image that named as chart. We'll include this image in the document. We'll include the image using the command /include graphics curly bracket image name. Then we save it, then process the LaTeX code. As you can see, the image has been included in the document. Now let us see some options which are available while we include any graphics or any figures. The first option is width and height. The next option is scale. Another option which you can use is the angle. Now let us try to use the option width and height. For including the option width and height, we'll use the square bracket. Inside the square bracket, we'll mention the width. Let's say we are mentioning as 10 centimeter and we'll mention the height. Let's say the height is 5 centimeter.
Save the document, process the code. As you can see, the image size has changed. Here the width is of 10 centimeter and the height is of 5 centimeter. Next, let's use the option scale. Similar as width and height, we'll use the scale option in the square brackets. Mention scale equal to, normally the size of the image is considered as 1. Say we want to increase the size to 1.5. So we'll mention scale as equal to 1.5. Save the file, process the code. As you can see, the size of the image has increased and it has increased to scale 1.5. Let's use the next option, that is angle. Similar to previous options, we'll use the square bracket and mention angle equal to a degree to which we want to rotate the image. If we use minus 10 degrees, it will be rotated clockwise to 10 degrees, and if we use positive 10, it will be rotated anti-clockwise. Let's see. Let's use negative 10 and process the code. You see, the image is rotated clockwise to 10 degrees. Let's make it positive 10 and process the code. Like you can see, the image is rotated anti-clockwise to 10 degrees. Supported formats while including graphics and figures. These are the supported formats. JPG is used when you want to insert photos. PNG is used when you want to insert diagrams. PDF can be included as images. EPS images can be included using the EPS to PDF package by just installing the package. Captioning and referencing figures. In LaTeX, captioning and referencing figures are important aspects of working with images, tables, and other elements in your document. They help you add informative labels to figures and refer to them correctly throughout the text, ensuring consistency and clarity. For captioning figures, we have to use the command /caption to add captions to the figures. Below is the example how to include a caption to a figure. We have to include two extra lines, that is begin figure and end figure, and inside that we have to include the image, then use /caption to give a caption to the figure. Now let's include the caption to the figure, which we already added previously. Like we learned, we have to include two lines, that is begin figure, end figure. Then inside these two lines we have to include the image, then using the /caption command we'll include the caption for the figure. Let's say the caption is figure of a chart. Let's save it and process the code. Like you can see, the caption is added as figure 1, that is figure of a chart. Now let's learn about the label command. The label command is used for referencing a figure. We include the label command using the command /label. Inside curly bracket, we input the referencing code. Here we have included as fig colon chart. Now let's add a label to the figure which we had already added previously. The code is /label curly bracket the label we want to add. Here we have added as fig colon chart. Save the code and process the code. As you can see, there is no change in the figure since the label command is used for referencing purpose. The referencing we'll see it later. For referencing the figures, we use /ref to refer a figure. This gives the figure number. We can also use /pageref to refer a figure which gives the page number of the figure. Here is an example. The chart is available in figure number /ref in curly bracket fig colon chart and page number /pageref curly bracket fig colon chart. Like in the example, we have used the two references /ref for referencing the figure number and /pageref to get the page number of the figure. Let's execute the code. As you can see, the chart is available in figure number 1 and page number 1. Like this, you can use the /ref and /pageref to refer any images which you have included in your document. Positioning figures. In LaTeX, positioning figures refers to where your images or figures appear on the page relative to the surrounding text. By default, LaTeX tries to position figures in the most optimal places. But sometimes you may want to control where they appear. For example, at the top or bottom of the page or close to a specific section in the document. While positioning figures in LaTeX, we face lot of challenges. Let's see what kind of challenges are faced while positioning the figures. So these are the placement options which are available to position figures. The placement option H is used to place the figure where it is mentioned. It is approximately placed at the same point it occurs in the source text. Next option is T. When T is used, the figure is positioned at the top of the page. Next option is B. The use of B placement option places the image or figure at the bottom of the page. Placement option small p. Put on a special page for floats only. Next placement option is the exclamation mark. It overrides the internal parameters which LaTeX uses for determining a good float positions. Capital H is used to place the figure at precisely the location in the LaTeX code. This is how we position figures. We use the placement options inside square brackets and include it in the first line, that is /begin figure. We can also combine options for better control of the positioning of the figures. Here is an example where it has used H, T and exclamation mark to better control the figure.
Let's position one of the figures. So we use square bracket. Within the square bracket, we put the placement option, say H. We save the code, execute the code. As you can see, the figure has come in the place where it has been defined. So the line referencing the figure and the page number has come below the figure. While positioning figures in LaTeX, we face a lot of challenges like inconsistent placement. LaTeX may move figures far from their definition point, leading to confusion for the reader. This occurs when there's insufficient space on the current page or due to other floating elements like tables. Next, excessive white space. Poor float placement might leave large gaps in the text, disrupting the document's flow. Next, float overflow pages. If numerous floats are defined within enough room, LaTeX may allocate entire pages for figures and tables, sometimes making the layout less reader friendly. Conflicting specifiers. Using strict specifiers, example H only, can cause errors if LaTeX cannot honor the placement, while overall flexible specifiers might lead to suboptimal placement. Next challenge is page breaking issues. Figures might get placed before or after their associated content due to page breaks, affecting the logical flow.
Figure numbering. In LaTeX, figures are automatically numbered when you include them using the figure environment along with the caption command. This generates the figure's title and assigns it a number. For example, the first figure will be figure 1. The numbering follows the sequence of appearance in the document and updates dynamically if figures are added, removed, or rearranged.
In LaTeX, figures are automatically numbered when you include them using the figure environment, allowing the slash caption command. This generates the figure's title and assigns it a number. For example, the first figure will be figure 1. The numbering follows the sequence of appearance in the document and updates dynamically if figures are added, removed, or rearranged. As you can see, this figure was our first figure, hence it was numbered as figure number 1. For figure numbering, we can customize the numbering using the command slash renew command. Use Roman numerals. This command is used to display figure numbers as Roman numerals. Prefix figures with section numbers. This command is used to include section numbers in figure numbering. Example, say figure 2.3 for the third figure in section 2. Customizing delimiters. You can also customize delimiters such as replacing a period with a dash. Adding prefix text. To add a specific prefix to all figure numbers, this command is used, like fig will be used instead of figure. As you can see, previously the figure numbering was given as figure 1. Let's use the Roman numeral for this. So I have included the command here just before the begin document command. Save the code, execute the code. Now, as you can see, the figure 1 has been changed to a numerical number. If you want to include prefix with the figure numbers, if you want to include the section number before the figure number will include the command this. Let's save the code and execute the code. As you can see, the figure number has changed from Roman numeral to figure 1.1, one mentioning the section number, and the second one mentioning the figure number. Restarting the figure numbering for chapters or sections, you can include the command /counter routine. Let's see an example to ensure how to reset the figure counter at the start of each section. We have to use the package chngcntr and then define the command /counter routine figure inside the curly brackets, then section inside the curly bracket. Here we have used the package chngcntr and use the command /counter routine figure and then section. Let's say we have two sections, figures in LaTeX section 1 and figures in LaTeX section 2. We have added two figures. First, a chart in section 1, then a mandala in section 2. Since we have used the counter routine statement or command, you can see the figure number for the section 1 figure is figure 1.1. Figure number for the figure in section 2 is 2.1. Here, the figure numbering has been restarted for each section.
Let's take a moment to check your understanding with a couple of quick multiple choice questions. These will help you review and solidify the concepts we have covered in this tutorial. If you answered correctly, great job. If not, don't worry. You can revisit the explanation in the video to clarify your understanding.
The correct option is option B, graphic X. The correct option is option D, that is exclamation mark.
List making environments. In LaTeX, list making environments are used to organize content in the form of list. There are several types of lists you can create depending on your needs, such as unordered list with bullet points, ordered list with numbers, and list with custom labels or descriptions. Enumerated environment. The enumerated environment in LaTeX is used to create numbered list. It is helpful when you need to display a list of items that follow a specific order, such as steps in a progress, ranking, or instructions.
In LaTeX, the enumerate item is used to create ordered list. Here is the syntax: begin, then enumerate inside curly brackets. Within this environment, we use the item command for each list item. For example, item followed by first number and item followed by second item. Finally, end and enumerate inside the curly brackets. This will generate a numbered list with the items first item and second item at the first and second entries respectively. As you can see, we have used the syntax to create an ordered list. And as you see, there is an ordered list starting with numbering 1 and 2 for first item and second item. In LaTeX, you can customize the levels of an ordered list using the renew command. For example, to change the default numbers to Roman numerals, you would use the following command: \renew command, curly braces, \label enum I equals
backslash Roman in parentheses enum I. This modifies the numbering of your list to display Roman numerals such as 1, 2, 3 instead of default Arabic numerals. Now let's use the renew command to change the numbering from Arabic to Roman numbering. As you can see, the code has been added. Let's execute the code. And as you can see, the numbering has changed from Arabic to Roman number. Itemized environment. The itemized environment in LaTeX is used to create bullet list. It's one of the most commonly used list environments, where each item is marked with a bullet point instead of a number. This environment is useful for when you need to list things in a non-ordered fashion, like steps, features, or any group of items that don't need to be in a specific order. In LaTeX, the itemized environment is used to create unordered list. Here's the syntax: backslash begin in curly brackets itemize backslash item followed by first point, then backslash item followed by second point, finally backslash end and itemize in curly brackets. This will create a bullet point list with first point and second point as the entries. As you can see, we have included the itemized environment code in the text file. Now let's execute the code and see what can be seen in the document. As you can see, the itemized environment with two items, first point and second point with bullet points. In LaTeX, we can customize the bullet symbols in unordered list by using the slash renew command with slash level init I. For example, to replace the default bullets with dashes, we can use this command backslash renew command curly brackets level item I, then the symbol inside the curly bracket. This will replace the bullet points in your list with dashes, giving it a different style. Now let us see what does the renew command does when you replace the bullet point using the dash symbol. We are using the code over here and we'll execute the code. As you can see, the bullet points has been replaced by the dash symbol. Description environment. The description environment in LaTeX is used to create list where each item has a label followed by a description or explanation. It's different from other list types like itemize or enumerate, where items are listed with bullet points or numbers. In a description environment, the focus is on pairing labels with descriptions, making it useful for things like glossaries, definitions, or detailed explanation of terms. In LaTeX, the description environment is used to create labeled lists where each item has a custom label. Here's the syntax backslash begin in curly brackets description. Within this environment, use the item command with a label in square brackets followed by the corresponding explanation. For example, backslash begin description inside the curly brackets, backslash item key 1 inside square brackets followed by the explanation 1. Similarly, backslash item square brackets key 2 followed by the explanation 2. Finally, backslash end in curly brackets description. This will create a labeled list where key 1 and key 2 are the labels and Explanation 1 and explanation 2 are their respective descriptions. Let's include the description environment example in the text file. As you can see, we have included the description environment code, and let's execute the code. As you can see, the label key 1 and label key 2 is added, whereas explanation 1 and explanation 2 are the description. The description environment in LaTeX is an excellent tool for creating glossaries or definitions. It allows you to pair a key term with its explanation in a clear and organized format. Here is an example: \begin, description inside the curly brackets, \item, algorithm inside square brackets, followed by a step-by-step procedure for calculations. Next, \item, data structure inside the square brackets, followed by a way of organizing and storing data. Finally, \end and description inside the curly brackets. When compiled, this will produce a labeled list where algorithm and data structure serve as the key terms and their respective definitions follow. This environment is especially useful in technical documents, academic papers, or any material where terms and their definitions need to be presented clearly. We have added the description environment used in glossaries. Let's execute the code and see. As you can see, the description environment in glossaries is used where algorithm and data structure are keys, where they are followed by their explanations. Generating new commands. In LaTeX, you can create new commands to make your document writing easier and more efficient. A command is like a shortcut that lets you define a particular piece of code or text that you use often, so you don't have to type it out repeatedly. This helps in reducing errors and making your document more consistent. In LaTeX, the /new command is a powerful tool for creating reusable macros, making your code more efficient and easier to maintain. For example, you can define a macro to simplify creating labeled items in the description environment. Here's the code: \new command, my list item inside the curly brackets, 1 inside the square brackets, followed by curly brackets, \item. Then text pf inside the square brackets, followed by #1. Now within the description environment, you can use this macro to define labeled items \begin in curly brackets description, \mylist item, then key inside the curly brackets followed by explanation 1, then mylist item followed by key 2 inside curly brackets followed by the explanation 2. Finally, \end in curly brackets description. When compiled, this will generate a label list where each key is bolded and its explanation follows. Using new command not only saves time but also ensures consistency in formatting across your document, making it particularly useful for larger projects or frequently used structures. As discussed, let's, let's use the new command by creating a macro mylist item, then using the macro mylist item in the description. This code is added. Let's execute the code. As you can see, the keys are bold over here, followed by the explanation. Before we wrap up, let's quickly check your understanding of the concepts we have discussed about list making environments in LaTeX. Here are two multiple choice questions for you to think about. Take a moment to reflect on your answers.
The correct option is B. Enumerate.
If you got it right, excellent. If not, you can revisit the explanations in the video to better understand how the enumerate environment works.
The correct option is C. /item.
Well done. If you answered correctly, if not, don't worry. You can always revisit the explanation in the video to review how the item command functions. Great work on these questions. Now let's summarize everything we have learned in this session. To conclude, today we have covered two crucial elements of LaTeX: figures and lists. We learned how to include and position images with a GraphicX package, add captions and references for better navigation, and customize figures numbering. On the list making side, we explored the structured formatting of enumerate, itemize, and description environments, along with how to create reusable commands to simplify your workflows. Figures and lists are more common than just visual or structural tools. They enhance the readability and professional quality of your document. I encourage you to practice these techniques and experiment with the customization options we discussed. Thank you for your attention. Let's make this document preparation with LaTeX a seamless and enjoyable experience.